Hello everyone, my name is Emanuele Giuseppe Esposito, and in this video we will see how confidential containers can be used to perform secure AI inferencing with NIM, Nvidia Inference Microservices on OpenShift AI. Let's start with the problem description. What are confidential containers? Since the very beginning, when we talk about multi-tenant environments, where one infrastructure is shared between multiple users, the focus was on what was running in the infrastructure. It could be dangerous, interfere with other processes, and this is also why we have virtual machines today. However, while this is still a valid concern, today the focus is also shifting to the infrastructure itself. An infrastructure that hosts multiple users has theoretically physical and virtual access to the user's data. Therefore, today we are not worried anymore about the dangerous workload, but instead consider it precious and are concerned that infrastructure has access to it too. In addition, regulations like DORA, the Digital Operational Resiliency Act, in Europe are now enforcing such security mechanisms. This is what confidential computing is about: preventing that infrastructure or system admin can access our data while it is running. But who is our potential attacker? Essentially, whoever has a physical or virtual access to the platform where your workload is. Note that we also consider authorized actors. It could be your system admin, platform or infrastructure admin, or Kubernetes admins. But what could they really do to access our data? Basically exploiting the fact that the data in memory is running as plain text. We group these attacks into class of problems. First, they could create memory dumps and scan for secrets, live memory inspection, and so on. Second, they could modify the software that is running, inject malicious code to leak data, create vectors, and so on. In order to solve the first class of problems, we use encrypted workloads and trusted execution environments, which basically make sure the whole memory of the system is encrypted. In order to solve the second class of problems, we use remote attestation, which essentially means make sure that both hardware and software running in our system have not been tampered with. Together, trusted execution environments and remote attestation are the basic pillars of confidential computing. Red Hat contributes and supports the Confidential Containers project, an open source project whose goal is to standardize and simplify confidential computing at Kubernetes level. In this demo, we will use OpenShift sandboxed containers, the Red Hat product equivalent to the Confidential Containers project. So what is actually a confidential container and what are its benefits? First of all, a confidential container runs in a confidential virtual machine, and in the case of peer pods, Kata Remote Hypervisor, the confidential virtual machine runs as a separate virtual machine parallel to the Kubernetes platform. This confidential virtual machine is supported by the trusted execution environment, and in this case of this demo, also the confidential GPUs, which provide confidentiality also GPU level. This means that if a platform admin tries to log into the pod, it will be forbidden, together with examining the logs. This is done to avoid data leakage. If the provider admin tries to physically or virtually dump the memory, since it has access to the platform, it will only get a bunch of encrypted data, or zeroed, depending on the hardware. If the provider admin also tries to log into the confidential virtual machine, that is also disabled by default. And lastly, in order to be sure that the trusted execution environment, the GPUs, CPUs, and the confidential virtual machine software stack have not been tampered with, attestation takes place to make sure everything is working as intended. Let's now look at the high-level setup. The public cloud provider provides the trusted execution environment and confidential GPUs. And with the PeerPods technology, we are able to run a confidential virtual machine parallel to the OpenShift worker node, which utilizes the provider trusted execution environment and confidential GPUs. An important piece in the confidential virtual machines are the trustee agents, which are configured to connect with the remote attester to perform attestation. Lastly, we have our container. In this demo, we will run an Nvidia Inference Microservice, also called NIM, running through OpenShift AI model serving. Even if we have such setup, we cannot already consider the whole environment, the confidential virtual machine software, trusted execution environment, and GPUs to be trusted. Therefore, we need to perform attestation to verify that the environment is safe. We will use the trustee operator, a confidential container attestation service running in a secure environment, in this case another cluster running in a protected environment. The trustee contains what are called reference values, in other words, the expected values that the CVM should produce. The first step into attestation is to generate the attestation report. To do this, the trustee agents in the CVM work with the OS and the trusted execution environment to get some information about software and hardware. Then, they also fetch information from the GPU and generate the attestation report. The report is then sent to the trustee, which will then inspect it and compare with the reference values. And if attestation is successful, in this case it will return a positive confirmation to the confidential virtual machines, confirming the container that the environment is trusted. Let's now look at the demo. In this setup, the cloud is Azure, which offers Intel or AMD trusted execution hardware and Nvidia confidential GPUs. On Azure, we also run an OpenShift cluster, and the whole confidential container setup is generated by the Red Hat OpenShift sandboxed containers operator. In the secure environment, we have the Red Hat trustee confidential compute attestation operator. To conclude, we have the Red Hat OpenShift AI operator that offers support for NVIDIA NIM containers. The NIM model used in this demo is the Llama 3 8B instruct model. It is a NIM model, which is a pre-built container for LLMs. And as NIM, it consists of container and a model altogether built to use a specially optimized CUDA accelerated runtime for all NVIDIA GPUs. The model is currently available on the NVIDIA NCG catalog. As said, without CoCo, we will just have the model running the Kubernetes node, fetching the container image and running the model inside of it. But as we can see, there are actors like the Kubernetes admin and cloud admin that are able to access the model. More specifically, there are various kinds of attacks they can perform, like sensitive info disclosure, data and model poisoning, and so on. The solution is with CoCo, confidential containers. The model runs in a confidential virtual machine backed up by trusted execution environments and confidential GPUs, but after downloading the image from the NCG catalog, it uses trustee to verify the environment can be trusted, and only then it can safely run the model. Let's now look at a practical demo. Let's start with our cluster. We have already set up an OpenShift self-managed cluster on Azure. And in the Azure Web UI, we can see how it is composed of one master and a single worker node. We don't need a lot or big nodes, since the model inferencing will run in a separate confidential virtual machine. Let's now go inside our cluster. In this cluster, we install the Red Hat OpenShift AI, which together with the serverless and service mesh operator provide all the tools to train and inference AI models on OpenShift. For the purpose of this demo, OpenShift AI also offers the NVIDIA NIM application, capable of running and serving NIM models. In addition to that, we installed the OpenShift sandboxed containers operator, which provides confidential containers to securely run OpenShift AI and, in this demo, NIM models. In a separate cluster running in a secure environment, we also installed the confidential compute attestation operator, also known as Trusty. This operator will perform remote attestation to check if the model is running on a trusted environment or not. Let's switch to the OpenShift AI view. We create a NIM project, and inside this project we already set up and run a NIM model called Llama 3 8B Instruct. We can also notice that the serving runtime is NVIDIA NIM. Let's talk a little bit about the model. This is the chosen one, and it's available in the NVIDIA NCG catalog. It is part of their NIM collection, and just like all NIMs, it consists of a container and a model, and uses CUDA accelerated runtime for all NVIDIA GPUs, with special optimizations. Okay, let's now look at the actual NIM container. We can see that, as previously said, it is up and running. Notice the container name, Llama Instruct Predictor 0004. In the Azure Web UI, we can see that now we have an additional virtual machine running parallel to the cluster, with the exact same name as the pod we just saw, Llama Instruct Predictor 0004. This is because this is the confidential virtual machine that contains the pod running our NIM model. We can also see that the instance size is standard NCC 40 ADS H100, where the second C stands for confidential computing, ADS stands for MD confidential CPUs, and H100 for the Nvidia H100 confidential GPUs. Indeed, in the Azure documentation, we can see that this instance is actually confidential, using confidential CPUs and GPUs. Let's now inspect our confidential container. The first thing this container does before running the NIM application is to check if the environment can be trusted, by performing attestation covering the software stack, but also the hardware, like CPUs and GPUs. Indeed, we see in the trusty logs that attestation happened and was successful. Notice how for this POC the logs are enabled. However, in a production confidential container, they will stay disabled. This is because default policies in CoCo disable the logs to prevent data leakage. Then, if we try to exec inside the pod, we can see that a generic exec via the web UI or command line fails. However, exec for specific commands is still allowed. This allows us to test any time if the environment is trusted and prevents any malicious actor from performing unauthorized operation inside the pod. Let's indeed try to manually perform attestation on the CPU. And then on the GPU. In the trusty logs, we can check how attestation worked, and we can see that all the checks passed. We can also see via the NVIDIA SMI command that the GPU is indeed attached and available for the NIM and CUDA libraries to be used. We can also see on the bottom that our NIM model is attached and using the GPU. Just to prove our point on policies, if we try any other command, we can see that operation is simply refused. We can actually also test this model. In the OpenShift AI web UI, we can get the inference endpoint to query the model. In this example, we set up a workbench to query the model. The only thing left to do is set the inference endpoint in the code and the API key if needed. We install the OpenAI package, and then the code will just create a prompt to query the model. And then we can write, for example, hello. And then we can also ask what are confidential containers. And we can see the model fully answers our questions. To show that attestation only works with confidential containers, we set up a separate project called NIM OAI. In this project, we run the same exact model, but without confidential containers. We will see how the attestation check fails because the container runs in a non-secure environment. First of all, we can see this container is also running with the peer pods technology, so it is running as a separate VM outside from the cluster. But the instance size this time is not confidential. Notice how the instance is NCADS and not NCCADS. Indeed, we see in the Azure documentation the NCADS doesn't have any confidential hardware. In this pod, we purposefully disabled attestation on boot, otherwise the container won't even start. We, however, still enabled the security policy to only allow some specific commands to run. We will now log into the pod and manually perform attestation. This is our trusty pod running in the secure environment, ready to get new requests. And now we can try to perform CPU attestation, and we will see that it will fail, since we are not in a confidential environment. And indeed, also in the trusty logs, we see how the attestation failed. To conclude, in this demo, we have shown how OpenShift confidential containers work, how to securely extend an OpenShift AI NIM workload with CoCo, and how CoCo supports Nvidia confidential GPUs to securely improve AI performance. This concludes our demo. Thank you and goodbye.